x. There we go. And for the second part, we have 3. And again, so we're all looking at the same thing. Maybe for some of your homework problems last night, you changed the zoom. Let's go zoom standard. So zoom 6. Now for the first one, for part A, we wanted to know where is it less than 3. So here's the line y equals 3. Here's our function absolute value of x. Where is it less than 3? Well, it starts right here. Here's the first part that it starts to be less than 3, continues to be less than 3 up here. So where does it go from? It starts here at -3 and goes all the way to x equals 3. Now what's convenient about that is it's one solid group. There's no disconnection between the two areas that it happens in. So for this one, our solution would be -3 to 3. Let's go ahead and put that down real quick. Let's go ahead and put that down on doc cam real quick. So where's the solution of that? It's from -3 to 3 and any value in between. Question real quick to you guys. Why is it not equal to? Oh, good job. Yep. If you plugged in 3 in here, the absolute value of 3, is it less than 3? No, that's not a true statement. It's equal to 3. So that's why there's no equal sign out here. Okay, let's go back to the calculator real quick. Let's take a look at the second part, example B. X, absolute value of x is greater than 3. Now let's look, where is it above the line, or where is it greater than 3? There's two parts. First off, it starts over here, not even on the screen in negative infinity. Keeps going down, down, down until it reaches 3. But then it takes a break. It's not true in this area because it's less than 3. So where is it greater than 3 again? Starts back up at 3 and keeps going up, up, up towards infinity forever. Let's go back and let's put the solution on the dot cam. So there are two parts to this. So it's not just one solution, there are two parts to that. It starts at negative infinity and it goes to -3. And then also it goes from 3 to infinity. Now let's ask ourselves a question real quick. Do we put parentheses? Do we put brackets? Do we put parentheses? Do we put brackets? Well, infinity, can you actually ever reach infinity? No, you can't touch that, so that one has to be a parenthesis. What about -3? If we put a parenthesis there, it means it includes every point up to it, but not -3. If we put a bracket, it's every point up to it and including -3. Would -3 make that statement true? Nope. So we put a parenthesis. Would 3 make that statement true? Nope. So we put a parenthesis. And because it's true both in here and in here, we put a U in the middle. What's that U mean in fancy math talk? That is the union. If you flipped it upside down, it's the intersect. So here's our solution, put as an interval, or put as a range, and here it is in interval notation. Okay, stop real quick, take questions on that. Okay, let's get down to some math though. Let's get down to it. Let's work some problems here. Let's get some work done. Let's take a look at 2 examples. And then actually that's it for this section. It's a much shorter section than what we had to deal with yesterday. Let's take a look. First one, let's go for the absolute value of 4 minus 2x is greater than 6. So for tonight's homework, the strategy I'd use, as soon as you get one of these problems, you have to look at where is our constant, where is our number. And is the function greater than the number? Is the function less than the number? Because some of the confusing things you're going to run into is they flip these around. Instead, the number's on the left, the function's on the right, and you use the rule that doesn't apply to that. So is the number less or is the number greater? And in this case, the number's less. So which one of these two is the number less? It's the bottom one. It's the one that actually has them separated out. So we have 2 parts to this one. The function is greater than a if and only if the function is less than the negative of a. So let's go to the first part. So the function 4 minus 2x. And it has to be less than the negative of a. So it has to be less than -6. When you think of that number line situation, it can't be that far away. Let's go to the other one. Again, look at our number. Our number is less than. That's the first part. The function has to be less than the negative of our number. Second part is our function has to be greater than our number, which makes sense. This has to be greater than that for its absolute value to be greater than that. So the second part is 4 minus 2x greater than 6. Some simple checks, because oh boy, this is the part people make mistakes in. Negative 6, it has to be further away than that. 6, it has to be further away than that. Some other checks, notice that 6, 1 it's greater than, 1 it's less than. With the negative 6 it's less than, with the 6 it's greater than. Now these are just algebraic problems like one we've dealt with before. Do note that we are probably going to run into dividing by a negative since we have a negative 2x in there. Okay, let's solve this out. First step, minus 4. Be careful with this. Negative 6 minus 4 doesn't give you negative 2, it gives you negative 10. Negative 2x less than negative 10. Divide both sides by negative 2. And again, warning, be careful. Now that you divided by negative, you have to flip the sign, so now x is greater than negative 2 divided by, negative 10 divided by negative 2 gives you 5. So x has to be greater than 5. Second part, do the same thing to the other side. Minus 4 from both sides. Negative 2 greater than 2. Negative 2x greater than 2. Divide both sides by negative 2. X greater, ooh, where did I make the mistake there? Yes, had to flip that sign. X has to be less than 2 divided by negative 2 is negative 1. So let's take a look at this one on the number line real quick. We have negative 1. We have 5. X has to be greater than 5. So we have to color in that side. X has to be less than negative 1. There's the visual on ours. Let's write it in interval notation. So we got to go from negative infinity to negative 1. Question, why parenthesis? Because it's not an equal to there. Union of that with 5 to infinity. So here's the representation in the equation, the visual, and our interval notation for our solution to that problem. Now, what's the solution mean to the original problem? It means you pick any number in this interval or any number in this interval, plug that puppy into the original equation, that will make that greater than 6 when you take its absolute value. So you plug in any number. You want to plug in 20 million, plug in 20 million, its absolute value is going to be greater than 6. You want to plug in negative 1.1, plug that in, its absolute value is going to be greater than 6. Good shot right now. Stop, check up, take questions. Question that came up here on campus. Should you put an open dot or a closed dot at negative 1? And should you put an open dot or a closed dot at 5? Now, that's a very good question. That's absolutely on your final. That's one of the points that you're either going to have or not have once you look at that notation. Open dot or closed dot here? Open dot. Why? Because it's not an equal. Open dot or closed dot at 5? Open dot, because it's not equal. Now, silly question. What would it be if it was equal to? You'd have to close in both those dots. Another question to follow that up. What would this look different if that was an equal to? Okay, good job. Yep, that would be a bracket. That would be a bracket. Would that one be a bracket? Nope, you can't actually touch negative infinity, so no, it can't be a bracket at that point. Good job, good question. Any other questions from you guys? Okay, one more example, last one for today, and then we're on our way. We have, for our last example for today, trick on purpose, 5 greater than or equal to the absolute value of 6x minus 4. Now, as I warned you in the last one, you got to look at the number. Is the function greater than the number? Is the function less than the number? Because for most people, just look, okay, it's a greater than, so I got to use the greater than one. Well, you got to look at where the function is, not how it's written in the problem. So for this one, I do want to take a look at the calculator again to check for reasonableness. A big theme through this Cohen book is checking with the table, checking with the graph, then using that as an estimate to check with your analytics. So let's take a look at this one on the calculator. Let's go and plug this one in. Let's put this one in the calculator. There we go. And let's take a look. Our function is 6x minus 4. And, oh, forgot the absolute value sign around it. Absolute value is 6x minus 4, and then we have 5 for what we want it to be. We want 5 to be greater than. So while we're doing that, let's take a look at our graph. Now, the question's going to be on this one. Do you want the range that's above 5 or below 5? Instructor, take a second to talk about that. Do you want the range that's above 5 or below 5? To be honest with you, most students are going to miss this one. They're going to say they want the range above 5. You want the range below 5. Because take a look at the original problem. What do you want to be bigger? The absolute value of 6x minus 4 or 5? And in this problem, you want 5 to be the bigger quantity. So you want this range below hand. You want this area in here. So let's just take an estimate real quick. Looks like it's a little to the left of 0, so we're probably going to want something small but negative. And then for our other end, 1, 2, looks like it's a little, maybe 2, maybe a little bit less than 2. So for a reasonableness check, there's a check to see where our solution will be. But let's work this out. Let's get the exact answer. So again, let's go back to the dot can. Again, you want the exact answer. If your life depends on it, you don't want people estimating it's about 1, it's about 2. You want to know exactly where that answer is going to hit. Most of you on campus don't know this, but my dad's an airline pilot, and the people in the back, they never say, I want you to land close to the runway. They always say, I want you to land exactly on the runway. So let's find the exact solution for this. Go back to our absolute value inequality theorem. Do we want the number bigger or the number less? In this case, we want the number to be the bigger part. So we want a to be the bigger value, so this is what we're going to use, that compound inequality. So we want negative 5 to be less than or equal to 6x minus 4 to be less than or equal to 5. To solve for x, add 4 to each quantity. Negative 5 plus 4 gives you negative 1, less than or equal to 6x, less than or equal to 5 plus 4 is 9. Okay, next step, divide by 6. So negative 1/6, less than or equal to x, less than or equal to 9 over 6. Now, is that the correct range? Yes, that's the correct range. Can we make that look prettier? Yes, we can make it look simpler than 9 over 6. Now let's go back and think of, was that reasonable to what we saw in the graph? We wanted something a little less than 0. Negative 1/6, a little less than 0, yep. Wanted something, it was a little less than 2, it was between 1 and 2. 3 halves is 1.5, absolutely. If you changed it to 1.5, would that be wrong? Nope, because 3 halves is exactly equal to 1.5. So this is the range of our solution. If we wanted to put it in interval notation, negative 1 over 6 to 3 over 2. Just on your own very quickly, brackets and parentheses. Okay, since you guys said so, yep, brackets because it's equal. Brackets because it's equal. There is the interval notation of our solution. Okay, that's what we got to learn today, basic inequalities. Tomorrow we're going to go on to some more complex ones when we've got quadratics, when we've got all of those other functions that we were talking about in section 2.2, when we got those involved in this. But